Let's go to LeetCode 2054. Two best non-overlapping events. For this question, it gives us two-dimensional array events. And let's choose two non-overlapping events and find the maximal sum. So because we just want to choose two non-overlapping events, right? So it will be much easy for us to do the two cases, right? And for if there is k, right, there is another question called scheduling Java, those kind of things, trying to choose k, right? We can use DP, right? Um, for two is a special case of the k, so we can also use DP approach. But for two, we don't need to use a dynamic programming way. We can iterate, right? For every events, we find possibly sort by the end time, right? And find on its right. If the start time is greater than this one, find the biggest um, start time, right? So that we just need to process the write, pre-process the write, called write max, right? But doing like this, there need a pre-processing that we need to pre-process and get array about write max, and we iterate twice, right? So we can actually do beta approaches. We separate those kind of events into points. One is a start point, and then another is end point, right? For this question, you say that because those time interval start and end, they are inclusive. So in order those kind of points is not being overlapped, right? We can add one more time unit to the end point. And we put use a list, right? Use a list. And for the list, put the array into it. So the array, the first element will be the time. And the second element will be a flag, which is entering event or entering point or leaving point. The third one is the value, right? So we sort this list. In first dimension is sort the list by the time. Okay, so that is index 0, right? And then we sort by if the time equals, we are going to compare the leaving events, then entering events, right? Because we add one more, right? We don't want to have that overlap between the end plus one with the start, right? So we are for the event flag, it is also increasing if we will add one, right? If we don't add one to the end of the end, we can sort the flag in a decreasing order so that the start is always before the end events. So either way, right? If you add one, then we have to, for the flag weight, sort in increasing order. And then if we have these points, so the thing is that we just need to look at these points, right? So what we want is we want to find two combinations. One is the end events in the previous round, and another is started events in the end round, right? Because the end events in the previous round, it will always have a interval associated with it. So this kind of value, and this start events, it will also have a cost or profit associated with this, right? So we add these two to compare with the global result. So let's write code for this. So let's set this one as list. What's the new array list? So what do we do? Set up for array event. We change this one as point. So at least add a new interval event 0. So this is the enter event and the value, right? And this is leaving points, right? So what we do is that we need to collections sort list. Right? So we can have a comparator comparing int. For example, um, A goes to first comparing by the first one is the time, right? And we can write then comparing it because we add the things that if we want to we don't add one to the end events, right? Then we need to comparing this one using a reverse order, right? For example, minus a one, right? So that the entering events will always count before the leaving events because they are inclusive. Otherwise, if there is one, right, added, then we just need to put this one as increasing order. Then we have result, right? Int result equals to 0. And we can have an events max equals 0, right? So what we do is for every point in this list, then we are going to have so if this is an enter event, P1 equals 1, right? Then we just update the result with comparing the maximum and the max plus P2, right? This is enter event. Else, this is a living events, right? So for the living events, we need to update the and max. So that will be max dot max and max and P2. So in the end, we just return result. It is n-log n time complexity and O(n) space complexity. And here, if we use list, this data structure is a bit slow, right? If you don't want to use list, you can also use an array, right? But since this array, two-dimensional array, right? You can use this kind of array, right? And for the length, um, because every event has become 2 points, right? So you can have this one equals 2n multiplied by 2, right? Multiplied by 3. That will get faster. And we can also write the Python code for this. So Python code will be, let's write the Python code. So we need a event list equals this, right? We have a real list. So what we do is that for every start and value in events, what we do is that the event list are going to append start one and value. And this event list, we are going to append this and plus one, right? And the minus one and the value. So we need to sort, right? So we need an analyst sort. So we need a write a lambda k equals lambda x. So that is we are going to sort the time first, then flag, right? Because we already add one to the end events. Otherwise, if we don't add one, right, you can use a minus x1. So what we do is that we're going to have result and the max, right, equals 0. There. What we do is for time uh, event type value in event list. Okay. So if event type equals one, this is an entering um, event point. So we are going to have result equals max result and max plus value. Else, that is start if equals one, that is starting point, right? We just find the previous and max, and else that is end events. So we just need to update the end max plus max and max and value. Right? In the end, just return result. So we are append with this is not a list. We can also call this as value, right?